All right, today we have the maximum product subarray problem. So this problem is actually very interesting because it's similar to another problem called the maximum contiguous sum subarray, but instead now we're dealing with products, and this problem we have to deal with not just only positive integers but also negative integers. So it'd be good to start with some examples, right? So let's start with some interesting examples, right? And start this. Okay. So first of all, it should be very obvious that in order to get the maximum product subarray, like in order to get the largest product, we like to have positive integers, right? Because a positive integer times another positive integer will get you a product that is going to be bigger. But then if you had a positive integer and a negative integer, you find the product of that, then that would be, smaller because it will go to the negative realm. So the trick here is that we cannot exactly forego or just forget about negative numbers, because what happens is in this example here, right? If you forget about this negative number just because it's negative, you're gonna miss the chance that when you take in count of the whole entire array, the last number, which could be negative, and it completely flip around the situation in the sense that instead of let me just take out this example for now. So currently we see that this is the maximum product. It's 4 because 2 times 2, and we're going to get 2 times 2 times negative 2, which was going to give us negative 8, right? Which is not the maximum product. But we want to keep this negative 2. Why? Because when we go to the end, we see another negative number. Because of that negative number, if we keep track of the product till now plus this negative number, then we're going to flip it around and have the answer become negative 8 times negative 2, which is from 16, which is much better than 4. So that's basically the trick of this problem. And in order to deal with that, we need to keep track of a running product for the maximum and the minimum. Why? Because the reason we want to keep, so hopefully the reason we're keeping a maximum is very clear, because positive numbers and we want the biggest product, right? But there's value in keeping the minimum product subarray as well, because up until the end this whole situation can change. You can see a negative number, and then the minimum product times that negative number becomes the largest product. So it's good to write some notes down. So want to track 2 running subarray products. So there's going to be a maxed product subarray, right? Max product, and there's going to be a minimum product, right? And so we're just going to start with a very simple for loop, and we're going to initialize some variables, right? Max product and equals min product equals nums 0. And we're recording the first number because in this problem we kind of have to assume there's at least one element in the array, because if the array they give to us is length of 0, then there's no valid product. And so we cannot give them a output. So assume that the problem has at least one element in the array, right? And so then we also want to keep track of our answer, right? Our final answer. because at the end, the maximum product, as we talked about before, might not be the actual answer. It might be the minimum product times the last element. So we're gonna loop through this. So for I and num enumerate, because I'm lazy and we want to get the key and the value like that, starting from 1, because we already took the account of the product, the first element, and then so then we're going to go through the entire length of the array, right? And now here's the fun part. So we need to keep track of this maximum product, right? And there's 3 scenarios which we need to keep account of what the max product could be. So the max product could be, put it here, the max product could be, we add the current element that we're on. So it could become max product times the current element, right? Or it could be the minimum product times the current element, because we also need to keep track, because like I said, it doesn't have to be the last number that's negative. If there's a negative number, like say here, we also want to keep track of that, because we cannot just drop any negative number, because in the end the whole situation can change. So we need to find the max between these 2 numbers for max product, right? So the max product would be the max of these 2. And actually there's a third condition, in that maybe we want to reset the subarray, right? So like, to make it clear, like here's an example where you might want to reset, right? For at least for our purpose of maximum product. So if we had a array that looked like this, which, you know, the last number is the biggest number, and if you count for those, it will become negative times 100, which becomes negative. So we just want to take the last number, right? So it just be the last number. Or you can just simply just think of this case, right? Yeah. So we also need to keep track of the minimum product, because the minimum product, if we go to the whole array, for example, it will tell us what is the minimum product before we hit the last switch. And that if it's negative, then the minimum product will actually become, when you multiply with the last element or within the next element, it will become the max product, right? So it's important that we keep track of the min product as well. And we're going to do the same thing. So it's going to be the max product times current number, and the min product times the current number. And we might also want to reset the array for min product as well. And so we're going to actually put that code in. Right? Okay. Now, we know that our max product up to this point and the min product up to this point. But now what we need to do is the answer has to be the max product, the max of the max product, and the previously known answer. Why is this important? Why is it not just max product? Because it's better to explain with the example. Let's say, what's a good example? Maybe here. So at our first iteration, we have max is 2 and min is 2. Answer is 2, right? Second iteration, our max is 4, min is still 2 because we're resetting the subarray, and then answer is going to be 4, right? Now our third iteration, so what happens is the max is going to stay at max products, or the minimum product. It's going to actually be 2. Sorry, 2. Serious. Yeah, I think it's -2 because we were going to restart a subarray, because if we did the current number, which is -2 times the max product, which is 4, it becomes -8, and then even times the minimum product, it will become -4, so we keep -2. And then min here would be minimum, so it will be -2 times the previous max product, which is 4, so it'll be 8. And here our answer is going to be 4 because we don't want to take the max value of this. So actually, I just noticed something else too. This might be wrong because once I do this, this part is going to go wrong. So in order to, because I already overwritten what max product is, so in order to for that not to happen, I'm going to put that on the same line so that max product is still the old value, right? And yeah, and then after this, we can just return the answer. And let's actually double check work. Oh no, int object is not enumeratable. Okay, I derped. I'm not supposed to actually enumerate here because I started with the 0 at the first index instead of the entire list. So we're just going to do now. So we're going to change this into range. And I already did not use num already, so that's perfectly fine. Okay, now let's run this. Cool. And so that test case passed. Let's try this one. Then I'm going to try my own. So on our last iteration, right? Our max, in this algorithm, our max will be the max might be 4, and min product will be actually max product will be 16. Why? Because of this line right here, right? Min is -8 times -2 becomes 16. So in here, what I think min would do is it will actually take it, or it might just stay as -2, because in this one it will be -2 times -2, which would become 4, which is greater than -2, and min product 8 times -2 is 16, which is 16, which is too big. So and then our answer will be 16. Let me just run this real quick. And let's try submitting. Alright, awesome. And there you go, guys. Hopefully that was helpful. See you next time.